Hello students, I am Makbul, Senior Chemistry Faculty in Narayana, Hyderabad. Today I am going to discuss January 29th paper, second shift. All these questions are collected from the students based on their memory. So these questions may be different in data or in sentence formation when compared to the original questions given by the NTA. Whatever the defect is there in the question or incorrect is there in the question, that will be resolved again after getting the original paper from NTA. See the first question. In which molecule dehydrohalonization forms maximum number of isomers excluding rearrangement? Dehydrohalonization means removal of hydrogen halide. It is an elimination reaction and it is a beta elimination reaction, and for that purpose you need to know beta hydrogen. Suppose if I take first option, in the first option there are two types of beta hydrogens here. If I say this is beta and this is beta dash, when this beta hydrogen and this bromine are removed, we get here a terminal alkene. For this only one isomer is possible. If this beta dash hydrogen and this bromine are removed, then we get internal alkene, and for which we can expect cis trans isomerism. So two isomers are possible. So for the first option the total number of isomers possible are 3. When you take second option, for second option there is only one beta hydrogen and this is the only beta hydrogen. If this hydrogen and this bromine are removed, then we get only one alkene, which is a terminal one. So one isomer is possible. And for third option there are two beta hydrogens, but both are identical. Whether this hydrogen is removed or this hydrogen is removed along with the bromine, you will get same alkene here. So only one isomer is possible. In the fourth case also we have only one beta hydrogen. So this is the only beta hydrogen available. If this hydrogen and if this bromine are removed, then we get only one alkene here and one isomer. So for the first question the correct option is 1. Coming to the next question here, which of the following complex has zero spin only magnetic moment? So this we can solve based on the crystal field theory, and we know this all options are given with octahedral complexes. So in crystal field theory we know that here when Degenerate orbitals are splitted in octahedral complex. We get two set of orbitals which are T2z and EZ orbitals. So the energy difference between these two set of orbitals is known as delta O. This delta O is influenced by the ligands. If it is weak ligand, here delta O is less, and here electrons cannot, when delta O is less here, if you take the electronic configuration with the 4 electrons here, the four electrons will have electronic configuration T2z 3 and EZ1. Because as delta O is less, the fourth electron can easily jump into the EZ orbital. If you take fifth electron here, then its electronic configuration will be T2z 3 EZ2. So 1, 2, 3, 4, 5. When you come to the sixth electron here, the sixth electron will be paired up with the first electron, then you will get T2z 4 and EZ2. So if total number of electrons are 6, then there is a chance of 4 unpaired electrons when ligands are weak. If ligands are strong, in the case of strong ligand here, delta O is high, therefore the fourth electron, rather than entering into the EZ orbital, will pair up with the first electron. So for 4 electrons, the electronic configuration will be T2z and EZ0. Similarly, if you take fifth electron here, its electronic configuration will be T2z5 and EZ0. If you take sixth electron here, the electronic configuration will be T2z6 EZ0. See, if there are 6 electrons, there is no chance of unpaired electron, then magnetic moment will be 0. So I am directly going to the option here. This is in the case of third option. So here in the rest of the 3, the magnetic moment cannot be 0 when you go for the go along with the electronic configuration given here. Coming to the next question here, which of the following diseases can be cured by equanil drug? This is completely memory based question here, and the answer is depression. And we know very well, for pain relief we use analgesics. For stomach ulcer or hyperacidity we use antacids. So for this question the correct answer is 3. I am moving to the next question. If Bose radius of hydrogen atomic ground state is 0.6 angstroms, find out Bose radius of third orbit of helium plus ion. Here we can write R1 by R2 is equal to N1 square by Z1 into Z2 by N2 square. Because we know that R is equal to 0.529 into N square by Z. So when you take the ratio, you will get the simplified formula. See, this is for hydrogen R1, and for helium plus this is R2. For hydrogen, Bohr's radius is given, that is 0.6 angstrom, and we have to calculate R2. And for hydrogen, this is 1 square, this is also 1. For helium plus, Z2 is 2, and we need for third orbit, so N2 square is 9. When you simplify this, then you will get R2 will be 2.7 angstrom. So moving to the next question. Compare the bond order of the following molecule. So this is based on molecular orbital theory actually. Even one doesn't know the molecular orbital theory, this question can be solved based on the number of bonds present in N2 molecule and O2 molecule. Here I am going to discuss this question based on the bond order of N2 and bond order of O2. Because if total number of electrons are same in different molecules, we can expect the same bond order. For example, if I take N2 molecule and which has a bond order 3, and for which electrons, total number of electrons are 14. The same number of electrons are present in carbon monoxide also, 6 plus 8, so 14 electrons. For carbon monoxide also, you can expect the bond order 3. Now, if I take O2 molecule and for which O double bond O is present, and totally 16 electrons are present here, the bond order is 2 here. Bond order is 2. But when you take NO molecule here, for which a total number of electrons are 15, as 15 is in between 14 and 16, and of course you will get the bond order intermediate to this 2 and 3, that is 2.5. And O2 minus 2, O2 minus 2 has totally 18 electrons. F2 is also having 18 electrons. So we know that the bond order in F2 is 1. So in this way you can solve this question without knowing the molecular orbital theory also. Based on the molecular orbital theory, you have to write the electronic configuration, and you have to find out the number of bonding electrons and anti-bonding electrons. Then bond order will be number of bonding electrons minus anti-bonding electrons by 2. But when we have a chance to solve the question easily, we can solve it in this manner according to me. So then correct option is here. The CO has bond order 3, NO has bond order 2.5, O2 minus 2 has bond order 1. So the correct option is 3. Moving to the next question. Which one of the following ores contains sulfide ions? Malachite is CuCO3 CuOH twice. Calamine is ZnCO3 and sphalerite is ZnS and siderite is FeCO3. The correct option is 3. This has sulfide ions. So moving to the next question. Ionization enthalpy difference from boron to aluminum is more than that of aluminum to gallium. So this statement is correct. For example, if you go for data for boron, ionization potential value is 801 kilojoules. For aluminum it is 577 kilojoules. For gallium here 579 kilojoules per mole. Here I am mentioning that this data only for the reference purpose, no need to remember that. So when you see the difference here from aluminum to gallium, the difference is very less when compared to the boron to aluminum. So the first statement is correct. And when you go for second statement, gallium has completely filled d orbital. So that is also correct. Because gallium atomic number is 31, it is very next element to the D block. That is after zinc 30 you will get gallium. So in the case of gallium, the electronic configuration is argon core 3d10 4s2 4p1. So it has completely filled d orbital. So both the statements are correct here. So correct option is 1. Moving to the next question. Which of the following relation is correct? So delta Z is equal delta H minus T delta S. This is a well-known equation in thermodynamics. In order to predict whether a given reaction is spontaneous or not, we use this equation, because when delta Z is negative, then only the reaction will be spontaneous. So when we have that delta H, delta S and temperature, we can calculate the delta Z, and if it is negative, that will be spontaneous, and as this equation is well known, it is given correct. Actually this is the answer. But whereas in the second option, we know that the relation between delta H and delta U, so delta H is equal to delta U plus delta N into RT here. But the given is wrong here. And the third option, P into delta V here is equal to delta N into RT. So this relation is true only for chemical reaction, because in a chemical reaction, when there is a change in number of moles, then there will be change in volume when pressure and temperature are kept constant. Suppose if I take a reaction, 2SO2 plus O2 gives rise 2SO3 here. There is a change in number of moles. On the reactant side we have 3 moles, on the product side we have only 2 moles. If it is possible to maintain same pressure and same temperature, due to the decrease in number of moles, there will be decrease in volume. So this is correct only in the case of a chemical reaction. When you go for ideal gas, for which PV is equal to nRT here. So for a given gas or for a given mass of a gas, this N is constant here. If you expect a change in volume here, then we should expect the change in temperature here. So that's why this is not true in all cases, so we can ignore this also. And anyhow, fourth option is none of these. So for this question, the correct answer is 1. Moving to the next question. It is from polymers chapter here. Of course, it is also memory based, and here as it is memory based, I can't discuss more. So thermosetting polymer is here urea formaldehyde. So for A, yes, here, and thermoplastic polymer is here polystyrene, that is R, and elastomer is, that is neoprene here, and fiber is polyester here. So for this question, correct answer is 2. But one thing you should remember, the difference between thermoplastic and thermosetting. If it is thermoplastic, re-hardening and re-softening is possible by heating and cooling. But in the case of thermosetting, once it is melted by heating and hardened after cooling, it cannot be remelted. That is thermosetting polymer. So thermosetting polymer cannot be repeatedly melted, whereas thermoplastic can be repeatedly melted by heating. Of course, elastomer has the property of stretching. So that's enough here about 9th question. Moving to the 10th question here. At 300 Kelvin, the ratio of RMS velocity and average velocity of oxygen molecule is given. The value of alpha will be. And we know that here VRMS here square root of 3 RT by M, and V average square root of 8 RT by pi M. Here M is constant and temperature is also constant, R is also constant. When you take the ratio here, V RMS by V average, it will be square root of 3 pi by 8 here. You can write this as 3 pi by 3 plus 2. So here the ratio given is alpha pi by square root of alpha pi by alpha plus 5. Then alpha value will be 3. And moving to the next question. thermal decomposition products of lithium nitrate are. We know that lithium nitrate decomposes differently from rest of the nitrates of the same group, but it shows a diagonal relationship with magnesium, and we know that magnesium nitrate decomposes to give magnesium oxide, nitrogen dioxide and oxygen gas. In the same way, lithium nitrate also decomposes to give lithium oxide, nitrogen dioxide and oxygen gas. Here one point I want to stress here, that is about NO2 and O2. Both are paramagnetic, but O2 is colorless here, but NO2 is reddish brown. Of course, the paramagnetic nature of O2 we decide based on the molecular algebra theory only, but in the case of NO2 molecule, its paramagnetic nature can be decided just by counting the total number of electrons. When total number of electrons are in heteroatomic molecules, when total number of electrons are odd in number, then we may expect paramagnetic nature. Of course, it is very important point, that's why I discussed here. But at the same time here, when you take other alkali metal nitrates, for example NaNO3, it decomposes to give NaNO2 and oxygen. Sodium nitrite and oxygen. It is not related to this question, but it is important one. So for this question, the correct option is here lithium oxide, nitrogen dioxide and oxygen. So third option. Moving to the next question. BOD value of drinking water ranges between. So BOD is biochemical oxygen demand. If water has organic matter, it may be polluted if that organic matter is more in quantity, and that organic matter is estimated by BOD or by using BOD. It is nothing but amount of oxygen required to oxidize the organic matter. For example here, if BOD value is very high, means that water is very polluted, it is unfit for drinking. For drinking water, the permissible value of BOD is less than here 5 ppm. That's why the correct answer is 1. Moving to the next question. Electroosmosis, electrophoresis, reverse osmosis, osmosis. If you know the definition of osmosis, based on the same concept, you can answer electroosmosis and reverse osmosis. So in osmosis, there will be movement of solvent molecules from low concentration to high concentration solution through a semi-permeable membrane, that we know that. So for osmosis here, the correct option is here P here. Solvent moves from low concentration to high concentration. But in electroosmosis also same thing happens, but it is under the influence of electric field. That is here colloidal particles move in the presence of electric field. that is not correct. Dispersion medium moves towards oppositely charged electrode across semi-permeable membrane. So this happens in the case of electroosmosis. Already I told you that osmosis and electroosmosis same concept, the only difference is applied electric field. But in the case of reverse osmosis, solvent molecules move from high concentration to low concentration solution. So when it will be possible means when you apply high pressure than the osmotic pressure, then only the solvent molecules move from high concentration to low concentration, and this method we apply to desaline the water, that is to get the water from seawater or to get purified water from bore well. So for reverse osmosis, the correct option is here, Q here. In the case of electrophoresis, and this is from surface chemistry, in the case of electrophoresis, colloidal particles will move towards their oppositely charged electrodes when electric field is applied. So that's why for electrophoresis, here the correct answer is yes. So for A R and B, that is S, and C, that is Q, and for D, that is P. So correct answer is 1. Moving to the next question, the ratio of de Broglie wavelength of proton to that of alpha particle if they are accelerated through the same potential. Lambda is equal to h by square root of 2m into q into v. Here we have to compare the lambda of a proton, de Broglie's wavelength of a proton, and alpha particle. Of course, here potential is the same and h is constant and 2 is also constant. We have to decide here based on the mass of alpha particle into q of alpha particle by mass of proton and charge of proton. When compared to the mass of proton, mass of alpha particle is 4 times more, so we can use this. And when compared to the charge of the proton, alpha particle has 2 units more charge here. Then you will get here root 8. That is nothing but 2 root 2. So the correct option is here 1. Moving to the next question. Which of the following is produced when propanamide is treated with bromine in the presence of KOH? It is also a very popular reaction and a Hoffman bromide degradation reaction. Propanamide is here CH3, CH2, CO and H2 here. When it is treated with in the presence of KOH, we get CH3, CH2, NH2, which is nothing but ethyl amine. So the importance of this reaction is here. This has 3 carbons here. Number of carbons are 3 here. Whereas the prepared amine has only 2 carbons. That's why it is known as Hofmann bromide degradation reaction. Of course, no need of mechanism for this. If one is known about the Hofmann bromide degradation reaction, can expect the product very easily. So for this, correct answer is ethylamine. Moving to the next question. Consider the following reaction. Major product P. Find the number of alpha hydrogens in the major product P. So this is even elimination reaction where carbocation is the intermediate. If carbocation is the intermediate, we should expect a rearrangement for better stability. See, I am directly writing the carbocation here. This is the carbocation formed when OH group is reacted with H plus. But it is a 5-member ring, but there is a chance of ring expansion where you will get a 6-member ring. So in ring expansion here, this will be 1, 2, 3, 4, 5 and 6. So this positive charge you can expect on the second carbon atom. Then you will get a 6-membered ring with the 2 branches and a positive charge. Now base abstracts the proton from the above carbocation from this carbon. Then you will get an alkene. So in this, number of alpha hydrogens are, here we have 3 alpha hydrogens, here we have 3 alpha hydrogens, here we have 2 and here we have 2. Totally we have 10 alpha hydrogens. So the correct answer is 4. Moving to the next question. This is again from the same chapter, amines here. This is Gabriel phthalimide synthesis. Of course, this question also can be answered even without knowing the mechanism, because in Gabriel phthalimide synthesis here, this nitrogen acts as a nucleophile and that will be substituted here and this will be removed. Then we get an amine. This is CH3, CH2, NH2. And this bond will be broken in the final step here by hydrolysis. Then we get phthalic acid. Actually, but this reaction takes place in the presence of a base. That's why you will get a salt. So here the correct answer is 1. Moving to the next question. The color of CrO5 in ether is. This is from chapter hydrogen. The color of CrO5 is blue, because we can prepare CrO5 by the reaction of K2Cr2O7 with hydrogen peroxide in acidic medium. Then we get here K2SO4 plus CrO5 plus H2O. See, CrO5 is blue in color. Actually, it is unstable. but it is stable. To make it stable, it is dissolved in organic solvent like a pyridine or ether. But one important point you should know about CrO5 is peroxy bonds. So CrO5 has 2 peroxy bonds or 4 peroxy atoms and 1 normal oxygen, where oxidation numbers are here for peroxy oxygen atoms -1 and -1, and this is -2. So oxidation number of chromium is +6. Because if you are following this video, you may be benefited for the next exam, because this is one of the important one. The oxidation number of chromium in CrO5 is +6. Our chromium peroxide has how many peroxy atoms? 4. Or how many peroxy bonds? 2. Like that. Moving to the next question. The number of voids in 0.02 moles of a solid which forms HCP lattice is. For FCC or HCP lattice, here tetrahedral voids is equal to 2 into rank. This you have to remember. Octahedral voids is equal to rank. So what is rank means? The number of particles present in one unit cell. See, for HCP unit cell, rank is 6. Then tetrahedral voids will be 12 and octahedral voids will be 6. The total number of voids will be 18. So this is in the case of one unit cell which has 6 particles. That means here 6 moles of particles which are present in one unit cell. There will be 18 voids, 18 moles of voids. But the question is 0.02 moles. So for 0.02 moles, how many? That is 0.02 into 18 by 6. This is moles only. As we need number, we should multiply with Avogadro number, 6 into 10 power 23. So when these two are cancelled, you will get this answer, 3.6 into 10 power 22. Moving to the next question. How many oxides are acidic? So here this is also a stock question. One should remember neutral oxides. CO is a neutral oxide, carbon monoxide. N2O, it is a neutral oxide, nitrous oxide. NO, here nitric oxide, neutral. Normally oxides of nonmetals are acidic except these oxides. So here acidic oxides are NO2, N2O3, Cl2O7, SO2, SO3. So answer is 5. Why that N2O3 or the remaining oxides are acidic means, when they are dissolved in water, suppose when N2O3 is dissolved in water, we get its corresponding acid, that is nitrous acid, or N2O3 is the anhydride of nitrous acid. See here oxidation number is +3, so one can expect its oxy acid with the same oxidation number. Similarly with the remaining oxides also we can expect the oxy acids.